Okay, so 1/2 mv squared, this is our formula for kinetic energy. And we could have derived it, I'm like, let's just look it up. I know it's on the internet somewhere, right?
Yeah.
It's got to be on the internet somewhere. 1/2 mv squared, well, what do you think m is? What do you think the m is? Yeah?
Mass.
Mass of your object, absolutely. What is the v?
Velocity.
Velocity.
So because kinetic energy is the energy of motion, we're going to say it's the speed. Is that cool? How you guys like that? Is that cool? So what we're going to do today is we're going to try to see, okay? We're going to use this situation here. I got to flip it around. Give me a second. Are you still trying to make a paper airplane?
No, I already did it.
You already did it, or you gave up on it?
No, I already did it. I'm gonna make a bigger plan.
Sorry, I moved my stuff. I should have moved it during lunch, and I forgot. I got distracted. All right. So we're going to explore. We're going to explore this. We're going to see how it goes. So, it's the best sound ever. Now, will you be the efficient car catcher? So it's like, I feel like you're giving me a lot of choice here, Don. All right, so here's what I'm going to do. Now, we're going to use this here, where I have the rubber band strung between the two posts here. We're going to use it like this. So we're going to pretend like our situation is like, oh, what if we had a spring here, and we're going to take our car and we're going to push it back against the spring, compressing the spring, and I'm going to let it go, and the car is going to come out here. Is that cool? You guys see how those two things are analogous? Where if you pushed it back against a spring, you'd be storing elastic energy in there. Same thing if I take this rubber band and I stretch it out this way. Okay, so I'm going to pull it back, I don't know, a little bit here. How's that? Cool? All right, put it back on the track. Okay? So, did you see how fast it went? Okay, I'm going to do the same thing here. You just said it, just push it right back on the track. That is very satisfying. I could just watch that all day. Okay. Oh my gosh, what happened? My gosh. Cool. So, how do I make it go? I'm sorry.
You still leaving?
Yes? How do I make it go faster?
Pull it back farther.
Pull it back farther, right? So if I pull it back farther, do you think it's going to go faster? Let's try. Here, I'll pull it back just a little bit. Well, that's very nice. All right, now I'm going to pull it back farther. You tell me if it's faster. Was that faster? Much, right? Okay, so here's what I want to know today. So open up to a new page. We're going to do an actual exploration here. Okay? We're going to do an actual exploration. And I want to know, so what are we changing? What are we measuring? What's the independent variable? What am I changing first, and then what am I measuring as a result? what's the relationship between the pullback distance and the speed? So this is like an exploration we're going to do here today. And we're going to, see girls, I did get the memo. I forgot to tell you, I did get our memo.
This
So,
is unintentional.
sure, right?
No, it actually
Uh-huh.
was.
We're going to explore this today, right? In a way that's kind of cool. And we're going to see if there's a relationship here. Now, yeah.
What example is this of like constant speed or like I don't even know what it is, like there's those moped bikes where you have to pedal for like to get a certain speed and then it's able to like keep that speed on its own. Like if you start the motor like not doing anything, it won't be able to do it, but like you have to pedal to get faster and then it'll be able to like keep it on its own. How does that work? Like how does it keep it constant when it needed someone to start it?
Is it motorized?
I think so. Like, normally they're like they have pedals so you can start up and then you like switch to motor.
So if it's motorized, then it's probably electric, or it could be gas powered. But then it would just be like like the same way a motorcycle works.
Oh, so it's just powered like how anything else is. So it's
Yeah.
not like okay.
Yeah, but it probably that like the motor doesn't work at low speeds. So the reason you guys don't drive stick shift cars. Anybody drive a stick shift car?
I'm learning how to.
What's that?
I'm learning how to.
Even in your car, right, when you start off, you'll hear it go, "Rrr, rrr." It switches. You hear the motor switch like that. It's actually switching gears. And so if you look on, let's say, a bicycle, like if you have like a 7-speed or a 10-speed bicycle or something like that, the one in the back on the back wheel, when you're in a low gear, it's easier to get going, and that gear is fat. It's like this big, right? And then they get smaller and smaller and smaller. And if you try to start off pedaling on that little tiny gear, it'll be really, really, really hard. So those motorized bicycles, the motor inside only works with the small gears. It doesn't have large gears on the inside. So you have to pedal first. Then when you get it up to enough speed that it has switched down gears, then it can go. It just doesn't have
it's
that.
able to stay constant because of gas or electricity. Okay.
Yeah. And so that's interesting because in that pie chart, right, the speed is always the same, so the kinetic energy is always the same, but you'd actually have to be losing a different part of it. So whether it was chemical energy from the gas or electrical energy from the battery. So, it's a great question. All right, so what do you think here? If I want to graph this, okay? If I want to graph this, what am I thinking is happening here? So this is the pullback distance here. PVD is pullback distance, this is the speed. Tell me what you think is true. If you have more pullback distance, what do you think is true about your speed?
More speed.
Do you think more pullback distance is more speed? Is that what we actually saw?
Yeah.
Okay. So what that means is that this is going to be some sort of direct relationship. As this one gets bigger, this one gets bigger. So it trends this way. In fact, if you have 0 pullback distance, what's going to be true?
0 speed.
0 speed, right? So we're going to be trending this way. So what I think is interesting is that we don't know the shape. Could it be linear like this? Is it possible it might be linear? It might be. We've seen that before, true? Is it possible it might be like a quadratic, like a parabola like this?
Yeah.
Okay? There's other kinds of graphs. There's actually, do you know what a square root graph looks like? A square root graph starts like this and gets less steep as it goes. It could be a square root graph. We don't know. Okay? We don't know, and that's the point, is we have a sense that as one gets bigger, the other gets bigger, but we just don't know how much. You all right?
Calculators fell out of my pocket, my bad.
You might need it later. All right, I have to move the whole table over here. Because I want you guys to take the actual data today and get it down, but we need the, basically we need the computer to tell us the speed. Does that make sense? So I need to attach it to the computer, it's over here, so I need to move the whole table this way.
You want help?
No, you are so sweet, I'm just gonna drag it and it's gonna make an awful sound.
Oh.
But I wanted you all to be ready for that moment. That wasn't even that bad. It's been worse. Okay. Where's Peabody?
I saw leaving school this morning.
He goes home for a third-hour tutorial because he's trying to limit his exposure, which I totally understand, but he probably fell asleep. You guys are prone to do that. It's all right though. Put that bad boy up. Okay, that looks good. Hello? You can do it. Assessment for tomorrow.
Do you want my books? How are you going to fix it? How are you even going to fix
Johnny, put that away. Why did you go to website? Oh, that's why. So we go do 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 do. Not that one. That one. There. Good. So here's what's going to happen: is we're going to roll the card. It's going to show the position and time of the car, and it's going to show the velocity of the car. This is going to be nice and fun. Actually, should be fun. All right. So I needed an official card launcher. Who wants to be the official card launcher?
Get up there, man.
What's that, John? You want to do it?
I'll do it.
Come on up. Okay, now, it's going to take a little bit of effort. Okay? I know. I mean, you got this though. So you can see how the front is at 200, right? So you're going to pull it back here so it says like 203. And then you're just going to let it go.
I got you.
Is that cool?
Yes.
Get the,
What do you want me to do?
All right. Are you guys ready? Because I can't do all the jobs. I can just do some of the jobs. All right, I'm so excited. Go ahead. So there's a slight delay in the showing of the data. But here's what I like, is that, hello. He was holding it, holding it, holding it. This is where he let it go. And the position decreased the whole time because it was moving toward the zero. Does that make sense? And what do you notice about this? Is this pretty linear here? It is, right? Which means that it was going at a relatively constant speed. And if I look down here at the speed, I can get a value. Now, if you're paying close attention, you can see that, you see how this slopes up just a little bit? That's because it was actually slowing down just a little bit. But I want to know what the speed was when he let it go. So to get that, I'm going to take the slope of the position graph is the speed. And so the speed when he let it go, now it's giving me the velocity because it was moving this way, so it was negative, but the speed was 0.39. All right, so let's start a data table here and see if we can make the data table make some sense.
Should I sit down?
No, you're good, you're the whole time. So this is the pullback distance. We measured in centimeters, and this is going to be the speed. And I measured meters per second. All right, how far did you pull down back? 3?
2 or 3, yeah.
203, so 1, 2, 3. So he pulled it back 3 centimeters, and the speed was what I say, 3.9? Now, again, it says negative 0.39, but we're going to go speed, not velocity. So I'm good with that. All right, this time, you're going to pull it back 6 centimeters. Got it? Wait, gotta wait. Go ahead.
Oh my god. I don't know how to do this.
So, you're good. Just put one hand on the front and one hand on the back.
Oh, that makes more sense. Okay.
Let me know when you're ready.
Okay, I'm good.
What? Okay. Cool, so we got something similar here. I need to take the slope. My computer does not want to. All right, 0.74. So you pulled it back 6 centimeters and 0.774, 75. Let's see. 75. Okay. All right, can you do 9 centimeters this time? Pretty good. So 1.08. Can we go 12 centimeters? That seems like a lot. Can you do 12? Oh god. Seems like a bad idea.
I think this is gonna fly off. Oh, no good.
.44. All right, so okay, so we have the data now, correct?
I'll sit down now.
Yeah, I feel actually really good about this, okay? We have the data, and so I want to know, is there a relationship between the pullback distance and the speed, right? So if you're playing along at home, if this was a linear, how would I know if this was a linear relationship?
It would increase by the same amount on both sides.
Right, it increased by the same amount. So let's see if it's in that ballpark. So this one increased from 0 to 3 was 0.39, and then it was 0.75. So that's an increase of like 30, how much, 36? So it went from 39 to 36. That actually isn't too bad. And what about going from here to here? That's 25. Well, that's like 33. And then from here to here, that's 30, what? 37, 36. So we have 39, 36, 33, 36. Does it look like it changes pretty consistently the whole time? I'm getting a sense that this might be linear. That's very cool to me. Or think about it this way. I know if I double the independent and I double the dependent, that would be, right? But this goes from times 2. This isn't really times 2, but is it close enough? I mean, let's do it this way. Let's go from 6 to 12. I go from 0.75 to 1.44. It would be 1.5. Is that close? All right? So what we're going to have to do, though, is we're going to have to plot it with n plot, right? We're going to have to plot it with n plot, and we're going to have to see whether it's an actual like linear relationship or not. Because I think that's going to give us some indication as to what's going on here. Because I think that's really cool. Okay? Here's the other thing we're going to do, and we're going to do this stuff tomorrow. But when I look at the bar charts or pie charts for these, either one's fine. What's our pie chart situation here? What's all our energy to start? What's all our energy after? Where's all our energy when we start? It's all elastic, right? 'Cause it's all in the spring, in this case, the spring of the rubber band. And what about after? So it's mostly kinetic, right? Is there a little bit of thermal? Well, tomorrow we're going to figure out how much thermal there is. Okay? Tomorrow we're going to figure out how much thermal there is because we're going to calculate the amount of elastic energy to start, and then we're going to calculate the amount of kinetic energy after, and we're going to see if we have, 10 elastic energies and only 9 kinetic energies. We're going to know that there's one thermal energy. Does that sound good? All right? Is that cool? So we're moving from our conceptual, our qualitative understanding into our quantitative understanding so that it kind of makes a little bit more sense moving forward now. Here's a real question. Have we measured things with a meter stick? Distances and stuff. What is the unit we've been using since the beginning of the year for distances? What is it? Good. We've been using centimeters and meters. What do we use in our everyday life?
Inches and feet.
Inches and feet. And if you want to go farther, what do you use?
Yards.
Yards and
Miles.
miles, right? So in the classroom, we tend to say, let's use meters or centimeters, right? Is that cool?